This is a video lesson on quadratic function and how to convert from one form to another, specifically from standard to general form and back. So just to refresh your memory about what those forms are, or to show you if you didn't know, standard is the name of the form that we first learned when learning about the quadratic function. It's the one that has the h and k, the vertex, embedded, and has an a outside of that x minus h bracket all squared. General form looks like this, is a times x squared. This a and this a are the same a. They will always be the same. When you're converting forms, the a value will never change. And b and c are two different coefficients, b the coefficient of the x term and c the constant. So how to convert from standard form to general? Well, this is probably the easier of the two conversions, one way and the other. Because to get to general form is the one that everything is all multiplied out. So all you have to do is use your algebra skills and multiply everything out. As a first step, you would expand this binomial. Remember that x minus 3 squared means x minus 3 times x minus 3. So it becomes this after you FOIL or double distribute. Then I would multiply everything by 2. Notice that here I just grouped like terms together. I would multiply by this numerical coefficient, that 2, it's the specific a value, and then group any like terms. In this case, there are these two constants. So what that means is that this original version whose a value is 2 and whose vertex was at 3 and 1 is the same as this. Notice that the a values are the same. So that's how to convert from standard to general, just expanding and grouping like terms. Going from general to standard is a little bit more difficult. And in fact, there are two different methods. And in this video, I will only show you one of them, and we will look at another one in a different video or a different class. And when you're asked to do some work today, it may be referring to a different method, but you can use this one. Both methods will give you the same answer. So first up, you will find the axis of symmetry. That axis of symmetry is the x value, which is equal to h. Basically, it's saying that h is equal to this formula, negative b over 2a, where remember that b is the coefficient of the x term in general form. A is the coefficient of the x squared term. So that's how I'll find my h. And if I want to know what the k value is, I will plug that h into the function in any form. So that's how I'll end up with hk. And then I know that a has to be the same for both. So I'll just replace in my h and k. So here's what I mean by that. So first up, if I'm starting with this 4x squared minus 24x minus 5 equals y, or f of x, to convert that to standard form, my first step is to use the formula. That formula is the x is equal to negative b over 2a. So remember that a is the coefficient here, a is 4, b is the coefficient of the x term, that's negative 24, and c is the constant, that's negative 5. So using that formula, x equals negative b over 2a, that negative sign is fixed, so I will have negative 24 over 2 times 4. And when I simplify that, my x value is 3. That means my h is 3, and when I write it out, it will be in brackets x minus 3, because there's a fixed negative in standard form. So I know that my vertex has an x value of 3. To figure out the k value, or the y value of the vertex, I'd have to plug 3 in as my x into the form that I have. And I'll have to plug it in here and here. I'll plug it in two places. And when I do that, I end up with negative 41. That is the y coordinate of my vertex. That's my k. And to write out my final answer, all I have to do is plug it into the template. I know that my a value has to be the same as it was in any form. So I know now that my h is 3, that my k is negative 41. My a from general form is 4. That means that it's always 4 in any form. So I just plug them in. That's going to be my standard form of this function.